a ton of uses, but one of its best uses are when you're trying to apply it for equations and inequalities and systems of equations and inequalities. Um, because it not only does it graph the line for you when it's in slope-intercept form, it also graphs the line when it's not in slope-intercept form. So for instance, if I have the line in standard form that says 2x plus y is equal to 3, right? There's my line, okay? And as you can see right here, here's my x-intercept and my y-intercept. So it also comes up with some really key points. Also, what I can do here is come up with a table of values here for this. Ooh, I guess I can show you that when I put it in slope-intercept form. So one of the things I can do here is, what if it was in slope-intercept form? So remember, this is the same line as y is equal to negative 2x plus 3. Okay, so again, here's our line, our y-intercept and our x-intercept. And I can come up with points on that line using the table function under my wheel. Okay, so what about a system of equations? Well, let's say that I had two equations. I'm just going to go ahead and type them here. Now, what's nice about this is if they're in slope-intercept form, I can graph them. So let's say I had y is equal to, so normally when we are solving a system by graphing, we put them into slope-intercept form. So let's do y is equal to 3x plus 2, and then let's do another equation. Y is equal to negative 1/2 x plus 3. Okay, and as we can see right here is the solution to the system of equations. Remember that a solution to a system of equations is where the two lines intersect. Now, what if these two lines were parallel? If these two lines were parallel, we know that there would be no solution and they would never intersect. So let's take a look and see what those would look like. Okay, so these both have the same slope, a slope of 3. And you can see that they do not intersect, but they give you x and y intercepts of each graph to help you graph it. Okay, so let's pretend that we have a couple systems that do have a solution, and we don't have them in slope-intercept form. Well, Desmos allows you to type these in not in slope-intercept form. So let's look at one equation. X plus y is equal to 4. Okay, so that line is actually drawn right here. We have x and y intercepts. All right, and let's say I wanted to see if there was a solution to this system where I have 2x minus 5y equals 15. Okay, as you can see, they've highlighted each line in appropriate color. So as you can see right here, the first line is in green and the second line is in purple. And here is the point of intersection where the two lines intersect. So I didn't even have to put them in slope-intercept form in order to find the solution to the system of equations. So this is an excellent way to check your work, especially if you're solving by other methods. Okay, so let's try another one. Let's see. I'm going to try to see if I can find one that has let's go ahead and do, let's do another one. Let's do 6x, oops, 6x plus 2y is equal to negative 26. See how this is helpful, especially if you have some really wonky equations, right? And then let's do x minus 6y, and notice that it's in another color, which makes it really nice, equals 21. Okay, so if I zoom out, there is my intersection point at -3, -4. So these both have a solution. The system to this system of equations is -3, -4. Now, what if we're graphing inequalities? Okay, that's another one that we're like, what the heck is that? So if again, normally we have you put them in slope-intercept form. All right, but I don't need to do that, which is really nice, okay? And I have all these inequality symbols here. Remember that if it's greater than or equal to or less than or equal to, I have a solid line, and if it's less than or greater than, I have a dotted line. Less than, I shade below, and greater than, I shade above. But what's really nice is your calculator does this all for you. And you still don't have to have it in slope-intercept form. So let's look at one equation. So if I had 2x, or inequality, so I have 2x minus y, let's have that be greater than or equal to -3. Okay, so if you notice, if we were to solve for y, we would have had to divide by -1, which is the coefficient of y right here. So we would have had to flip the sign. This has already done it for us. We have a solid line, and we're going to shade below because we would have had to flip the sign, right? So this is what it looks like, and you can match this to other graphs and stuff like that, especially when you're using doing the SOL. Now, what happens if I'm trying to do a vertical line? Let's see if that works. X is greater than or equal to 3. All right, so that's a vertical line. It's to the right of 3, and I have a solid line. So it's okay if I use these here. And if I wanted to see, what about if it was y? Remember, that's a horizontal line. Y is greater than or equal to 3. That's shading above. Okay, now if we have systems of inequalities, remember, we're trying to see where the two sets of shading overlap. That's the solution. So let's go ahead and do one. So I have y is less than or equal to, let's try 2x plus 1. Now this one is really nice in slope-intercept form, so I probably could have easily done that myself. But then let's do 2x minus 5y. Now this one is in black, right? So 2x minus 5y is less than or equal to 10. Okay, so that one we're again dividing by a negative, so we're going to be shading above. Now here is the solution to this inequality, and here is the solution to this inequality. The solution to the system of inequalities is where the shading overlaps, and that's really easy to see right here. Okay, so I would be remiss if I did not show you how to do this on Desmos and use this as a tool. Now, I still want you to be able to graph inequalities and put things in slope-intercept form, but this is an excellent way to check your work, and also if you're doing your SOL and you're able to use Desmos, which you are on the Virginia SOL, this is a great resource for you. It'll save you a lot of time, save you a lot of heartache, and basically it gives you the answer without even having to think about it. All right, hope this helps.